Hi guys, welcome back. We're going to talk about covalent compounds in Chapter 6. Our goal for you in this chapter is that you can describe the formation and characteristics of covalent bonds, that you can write the correct formula and their name, and then draw Lewis structures. Using those structures, be able to recognize various molecular shapes that covalently bonded molecules can exhibit. We're going to start our discussion with Section 1, where we'll talk about covalent compound basics. Our essential questions is that what are covalent compounds and how are they formed, and then what are the common properties associated with them. We're going to go ahead and start with a little bit of chemical compound basics, looking at chemical bonds. Remember that a chemical bond is the force that holds two atoms together, and they're going to be bonding to one another because they do not have an octet yet. They're not stable. So even though they're neutral, our atoms are neutral, they're not stable. So what we're going to do is we're going to form bonds with other atoms so that we have a full outer energy level. And remember, the octet rule says that atoms are going to lose, gain, or share electrons in order to achieve that octet, with the exception of hydrogen, because hydrogen only has one energy level, so hydrogen is full when it has two electrons in its outermost energy level. Again, there are two major types of compounds, ionic and covalent. Another word for covalent is molecular. So with the ionic, in our last chapter, we saw that electrons were gained and lost. The cation lost and the anion gained. In this chapter, we're going to learn how atoms can share those valence electrons. So in our last chapter, we really focused on ionic compounds, and we learned that ionic bonding occurs when one atom loses and the other atom gains electrons, and it occurs when a metal bonds with a nonmetal. And we have the formation of ions, which are charged atoms, and they're charged because they no longer have an equal number of protons and electrons. If they're losing or gaining electrons, we are going to end up with a positive or a negative charge. The positively charged ion is called a cation, and those are the metals, and then the negatively charged ion is called an anion, and those are the nonmetals. Now, our cations are attracted to the anions and vice versa because they have opposite charge. So we saw, for instance, potassium and fluorine bonding together because potassium has one valence electron and it wants to lose it. It's our metal. Fluorine is a 7A element and it wants to gain one electron. So potassium ends up giving its electron to fluorine, and when that occurs, potassium ends up with a 1+ charge because it lost one, and fluorine ends up with a 1- charge because it gains one electron. And here's our ChemCat joke for you. A covalent bond yells at an ionic bond, "Didn't anybody ever teach you to share?" So in this chapter, we're going to focus on covalent bonds. Covalent bonds are going to form because of the sharing of valence electrons between two nonmetals. So remember, those nonmetals, they both want to gain electrons. So neither one of them wants to lose. So what they're going to do is just share the electrons involved in between the two atoms to get their outermost energy level full. So we have two chlorine atoms. Both of them have 7 valence electrons and they want to gain one. We see that we're going to move closer together and we're going to share these 2 valence electrons. When we do that, each chlorine ends up with an octet. And so therefore, each chlorine atom is stable. And we call the shared pair of electrons between them bonding electrons. And we're going to replace the dots in our Lewis structures with a dashed line to represent those bonding electrons. So these are shared paired electrons, and this becomes the chlorine gas molecule Cl2 when bonded. You have a joke about covalent bonds? Do share. So molecules are going to form when two or more of the atoms that are usually nonmetals covalently bond. So when we have a covalent bond, we're going to see the formation of molecules. A diatomic molecule is a special type of molecule in which there is two atoms of the same element that are bonded together. So they're sharing electrons between two atoms of the same element. We call these the Hofbrinkel twins. That's one way to remember them, the Hofbrinkel twins. Each one of them has two, and that's where the word twin comes from. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. And so we have two hydrogens bonded together, two oxygens bonded together, and so on. But one thing I want to go ahead and draw your attention to is when you look at the picture here, notice that they are forming molecules that have more than one bond sometimes. So oxygen, for instance, has a double bond between it, and nitrogen has a triple bond. So just notice that they have different numbers of bonds that are forming between them. We're going to see this in a few slides later, talk about how we can predict the number of bonds that will be formed. So molecules that contain at least two different elements are covalent compounds if they're covalently bonded together. Now these are weak forces of attraction between the molecules, and therefore they only require like a small amount of energy to break them. Therefore, they're very different properties than the ionic compounds. So for covalent compounds, they could be a solid, a liquid, or a gas at room temperature. If they're a solid, however, they're going to be kind of soft and relatively flexible, malleable. They're going to have low melting and boiling points because they have they don't require a lot of energy to break those bonds. They're going to be fairly insoluble in water, which means that they're not going to dissolve in water very readily. And then they will be poor conductors of electricity in all phases, as a solid, liquid, or a gas. They're just not going to be conducting electricity very well, if at all. So let's go ahead and make sure we understand there are three common types of bonds that can be formed between the atoms in covalent compounds. A single covalent bond will have two electrons being shared. So one pair of electrons are shared between two atoms and they form one bond. Hydrogen gas is the example for a single covalent bond. Double covalent bonds will occur when there are two pairs of electrons, so four electrons that are being shared between two atoms. So oxygen, when it bonds to itself, they each want to gain two. So since they are sharing a total of 4 electrons, they will form a double bond. Other elements are phosphorus, carbon, and nitrogen that will form double bonds when bonding diatomically. Triple covalent bonds occur when there are 3 pairs or 6 electrons shared between two atoms. So nitrogen gas, since it wants to gain 3, if we have two nitrogen atoms bonding together, they're going to form a triple bond. Carbon can also triple bond. What's kind of cool is we can predict the number of bonds that will be formed for an atom. We know how many electrons that they need to gain in order to form an octet, and that's going to be the number of bonds that they will form. And we kind of indirectly have this information on our periodic table already. So when we look at group 7A elements and hydrogen, they each need 1 electron to form their octet or to have a full outer energy level. So since they need 1 electron, they're going to share 1 electron and form 1 covalent bond. Group 6A elements, however, they need 2 to make 8. 6 plus 2 equals 8. So they're going to share 2 electrons and form 2 covalent bonds. Now they can do this as a double bond if they are bonding to one atom, or they can bond to 2 different atoms and have single bonds. Group 5A elements need 3 electrons, so they're going to share 3 electrons to form 3 bonds. Again, group 5A means that if we have like nitrogen, we can put a triple bond between 2 nitrogen molecules, but we could also have nitrogen being a center atom. Remember our Fruit Loop lab that we did, and we noticed that when we bond nitrogen, it can bond to 3 different atoms. So it can form 3 single bonds. And then group 4A needs 4 electrons, so it will share 4 electrons and form 4 bonds. So the number of electrons that our nonmetals need is the number of bonds they will form. Alright, hit pause on the video and answer these 5 questions in the summary section of your notes. And then come back and check your answers. How many electrons are shared in a triple bond? That is like asking you how many shoes do you have if you have 3 pair of shoes. So since we have a triple bond and there are 2 electrons per bond, we know that there are 6 electrons shared in a triple bond. Number 2, how many electrons do group 4A elements share? So group 4A has 4 electrons and it needs 4 more. So they will share 4. Number 3, predict the number of bonds needed for group 5A elements. So group 5A has 5 valence electrons. They need 3 more to have 8. Therefore, they will form 3 bonds. So remember, the number of electrons needed is the number of bonds formed. Number 4, how many bonds will selenium form? So you have to look at selenium on your periodic table. So take a second and do that. You will see it's a 6A element. So hopefully you said it will form 2 bonds because it needs 2 electrons. And then finally 5, what are the properties of covalent compounds? Remember that they can be a solid, liquid, or gas, but if they're a solid, they're going to be flexible. They have low melting and boiling points. They're insoluble, meaning they cannot dissolve in water, and they are poor conductors of heat and electricity. All right, thank you for sticking with us, and there is our Section 1 notes. Make sure that you turn in your notes. Get a quick check so that you can get your assignment. Thank you. See you next time.